Let's get right into it. We're going to try and get inside the mind of an AI. When a large language model tells you something that's just completely wrong, you have to wonder, does it know it's about to lie?
Right? Think about it like a poker game. A person might have a tell, a little twitch or a nervous glance that gives away their bluff. So the big question for AI researchers has been, do these AIs have their own internal poker tell? Is there some little flicker in the code that basically screams, warning, I'm about to make something up? So a team of researchers decided to go on a digital manhunt. They wanted to crack these models open and find that one signal, that telltale sign that separates a hard fact from a total fabrication. But what they found was way more complicated and honestly a lot more fascinating than just a simple yes or no. It turns out not all AI lies are created equal. The investigation showed that these models tell two fundamentally different kinds of lies. And, well, understanding that difference is the key to this whole mystery. Okay, check this out. This example from the research really makes it clear. On the left, you've got what we can call an obvious lie. Saying Obama was born in Tokyo is, well, it's just a random error, completely disconnected from reality. But on the right, that's a plausible lie. Now, we know Obama wasn't born in Chicago, but he has such deep roots there, right? So it's wrong, but it feels statistically likely. So, the fancy term researchers use for that obvious lie is an unassociated hallucination. This is what happens when the model has really weak or just no information connecting the question to the answer. It's basically just taking a wild guess. But that plausible lie, they call that an associated hallucination. And this is the really deceptive one. Here, the model isn't just guessing. It's pulling from a very, very strong statistical connection it learned from its training data. The words Barack Obama and Chicago showed up together so many times that the model sees a powerful, credible link, even if it's for the wrong reason. So, the big question is, how does the AI see these two lies from the inside? This is where we get to peek under the hood, and the results are pretty wild. All right, so take a look at this. This chart shows the AI's internal confidence, for lack of a better word. Look how high that signal is for a true fact. Makes sense. But now look at the plausible lie. It's almost identically high. To the AI, the plausible lie feels just as correct as the truth. Meanwhile, the obvious lie, the signal is incredibly weak. So here's the kicker. The AI does have a tell for the obvious nonsense. But the plausible lies, they look exactly like the truth. And this quote right here, it just hits the nail on the head. These models aren't designed to check for truth. They're designed to recognize and repeat strong patterns. So that internal signal isn't saying, hey, this is factually correct. It's saying, hey, this is a really, really strong pattern I've seen before. So what does all this mean when we try to build systems to actually catch these AI lies out in the wild? Well, as you're about to see, this creates a seriously deceptive problem. It means our detection methods have a massive blind spot. Look at this table. We can build tools that are more than 90% accurate at catching those obvious, random lies. That's great. But when it comes to the believable, plausible lies, our success rate just plummets to around 65%. That's barely better than a coin flip. And that creates this really dangerous paradox, doesn't it? The lies that sound the most convincing to a human are the exact same ones that feel the most convincing to the AI. There is no internal alarm bell going off, not for us and not for the machine. Now, you might be thinking, okay, but that's probably just an edge case. But the research shows this problem actually gets worse in the very areas where we need the AI to be the most accurate. This chart is so revealing. When you ask about really obscure topics, the AI often doesn't have much data, so it makes a lot of these obvious, random guesses. But when you ask about popular, well-known subjects, the number of those obvious lies just nosedives. And why is that? Because for popular stuff, the AI has tons of strong patterns to work with, which makes those dangerous, plausible lies way, way more common. And this also explains that classic frustration we all have. Why can't these things just say, I don't know? Well, from the AI's perspective, it is sure. That plausible lie about Chicago creates such a strong internal signal that it feels like a fact it knows. The model literally doesn't know that it doesn't know. All of this really forces us to change how we think about what an AI is even doing when we ask it a question. It's not thinking or knowing in any way that we'd recognize. So here's the real takeaway. First, these models are not fact databases. They're not searching for an answer. Second, what they are is incredibly sophisticated pattern matching machines. And third, their one and only goal is to predict the next word that is most statistically likely to come after your prompt, all based on the patterns they've seen billions of times.
So, a plausible lie isn't some kind of intentional deception. It's just the system doing its job perfectly. It found a very strong pattern that just happens to be factually wrong in this specific case.
And that leaves us with one last really critical question. The research is clear. When an AI tells its most believable lie, its poker face is perfect. There is no tell. So if the machine can't even spot its own most convincing mistakes, who's left to check the facts? Well, that responsibility falls right back where it's always been, with us. Thanks for tuning in.